So today we will be hosting Felipe from Klong for the behind the scenes artist talk, building soundscapes through machine learned histories as part of our AI playground program led by Ambika, aka Computational Mama. Hey Felipe, hi Ambika. Felipe Sanchez is a creative coder and sound artist working in the field of music, interactive experiences, and digital arts. He is a co-founder of the Berlin-based studio Klong. In addition, he works as an educator across Germany within the field of music design, creative coding, and interactive experiences. Since 2013, he's been working professionally as an artist, a creative coder, and sound designer in the field of new media, borrowing elements from film, music, dance, performance, and new technologies, developing generative music and intelligent audio engines, creating sonic experiences based on interactive technologies. Welcome again, Felipe. We're so glad to have you here with us today. You can see Klong's work on klingklangklong.com, which I'm going to drop in the chat as well. So this workshop is the 8th event of the AI Playground program, led by Ambika and funded by the Stimulring Fund's creative industry. It is part of the sound theme among our 4 main program themes, including image, moving image, music sound, body poses, and text words. Under each theme, we are hosting one behind the scenes artist talk, like today's, and one workshop, like we'll be having on the 18th of October with Soyun Park. You can follow our social channels and keep an eye out on our Eventbrite page for other programs this year. I'm gonna drop some other links in the chat where you can find us and all the upcoming events. And here they are. Also, we'll make the explorations and learnings of each AI Playground topic accessible to the wider community with a public guide. You can find these guides on our website, which will also share some insights from on our social channels. Each guide contains an introduction to each discipline, inspiration projects, and creative suggestions for how the viewer can expand on the subject further. The event participants will have the chance to provide suggestions on what they'd like to see in the guide. Additionally, there's going to be an online graduation show later in the year where all of our program participants will have the chance to display the work that they developed in those sessions or work inspired by the events. More details will be announced on the respective Slack channels, and you'll be receiving an email on how to join the Slack space shortly after the talk today. Please don't hesitate to ping Ambika privately if you would like to contribute to the guide or the graduation show in some way. And I'm gonna drop the link to the Slack as well. Okay, without further ado, I'd like to leave the stage to Felipe for the exciting talk. Hello and welcome again, Felipe. Take it away.
Hey Brian, thank you very much. I'm very glad to be here. Can you hear me? Can you hear me good? Cool. Thank you very much. And thank you much for the invitation. I'm very glad to be here and hope I bring some interesting things, interesting inspiration for you all. So I'm just going to start. I'm going to share my screen. Just for you to know, I'm going just to go through the presentation, and if you have any questions or something like that, we're going to leave a little bit of time after the presentation to have questions. If there's something that you really want to say during the presentation, I don't see the whole, while I'm presenting, I don't see this screen, I just see my presentation. So scream if you have something to say, or you don't hear me, or you don't hear the music. So I'm going to share my screen right now. So can you see my presentation right now? Please say something, I don't see you. Cool, perfect. All right, so let's start. Like Brian said, my name is Felipe Sanchez-Luna, and I found in about 2015 the studio Klong. We were 4 founders, and at the time we were just working already 4 years. And today we understand ourselves like a studio for sonic experiences. We changed through the time. We started like a little bit in a company that were doing sound for advertising, for film. We were sound designers and filmmakers at that point. And very early in that process, I started to code like around 2012. And in a point very early 2013, one of my colleagues founders just gave me one Kinect, put Kinect on the table and say, let's see what you can do with it. And that started this journey where we mix technology and sound and music to create new ways of experiencing sound. So one of the things that we think that's very, very important is that we don't use technology just for the sake of it. There's some moments where it's inspiring, some moments we get inspiration of the new technologies, but what we want to do is to create very nice aesthetic sound experiences, and the technology is just a way of doing it. It's just a medium, but it's not the goal. So that's we create a lot of different methods in order to create these kind of experiences, like composition methods and audio engines and different kind of technologies around that. And yes, I think the one thing that is for us what will be very important always is that the technology is just a tool to create something much more important, much bigger than that. Okay, I'm going to concentrate this talk today also because it's the topic of today in music and artificial intelligence. We have tested and used a lot of other technologies, and I'm just going to show a part of our work that is based on AI. And before I started, I just wanted to have something a little bit clear, and is the difference between using AI in music and using AI in the image world or video world, because there's a very big, very central point that is a big difference, and that's that music and sound is sound based. When you're creating when AI is creating a image like the one you're seeing that's done by Midjourney, is analyzing or is creating some a moment in time that is freeze, right? Music doesn't have that. Music don't freeze in time. Your freeze in time music is nothing. So it's a time-based media. And the problem with that is the music is very dependable on what is coming next and what has happened before, and this dramaturgy. So this creating this dramaturgy through a piece of music is for AI very difficult to grasp, and also that needs a lot of computational power to do this kind of stuff. There's some methods is getting better, like always, every day is getting better. But it's a very big difference. Like you do first an intro to get to get to a climax, and this way of thinking, this time-based thinking, is very difficult for AI. So that's one of the things that makes AI in music not that advanced as in video and in pictures, but it's getting there, and it's going to get there in any ways in the next months because AI is just growing immensely so fast. Well, I'm going to go through a few projects of ours, and that also is going to go to the technologies that we have used and have appeared in our realm of music and AI. And the first one I wanted to present you is Meandering River. Meandering River is a project that we did in collaboration with Informative. And what they did, they call us, Cedric, the boss of Informative, called us saying, hey, we have this project, do you want to collaborate? We're going to do visuals and we need sound for it. And what they did, they were analyzing the way of how the rivers move through the landscapes, how they meander to the landscapes. And they wanted to do this beautiful, or they did this beautiful generated visuals based on data about how they move. It's not scientific. They use some papers, but it's very artistic. And this is one project that when they asked us, it was, I don't know, it was like 2015 when they asked us if we want to do this. And this is one of the projects that you don't have any budget for it or anything, just time. And so we needed to see when can we do this? When can we put it in our timeline, in our free time? So we were working like, I don't know, 2 years on it without really advancing. And we at the beginning wanted to use a Markov chain and some different generative methods to create the music. But when finally Informative came to us and say, hey, it needs to be done by February, that was 4 months in advance. We at that point we said, okay, we're just starting to smell, to feel the AI in music. There's some things that are happening. Google Magenta was starting to be part of our world, and we thought, okay, let's try this. Let's try to do something like that. And I got together with a good friend of mine that working with us in Klong at that time, Christian Losat, and we started to learn how to do this and how to code Python and so on. And it was very difficult for me because I can't come to the coding. I not really coding. I do MaxMSP, which is much object based, and V4 and Touch Designer. So, but he could code a little bit. So we started to learn and to see this whole Google Magenta kind of blocks, and end up trying into doing a piece that is actually very beautiful. That is showing, actually until today is showing. And what we did was, let me play this and do like this. What we wanted to have is the impression that the computer is improvising through to the visuals, right? So it's just the visuals are just running, and we wanted to have a computer that is analyzing the data and improvising to it. And at that point, we started with the architecture with the code for performance RNN, which Magenta did. So we took that algorithm and started to play with it. And we wanted to have different kind of pieces of music for the different looks. There are 10 looks. And what we did was to sit down 5 composers, because the great point was, okay, which database are we going to use? And we didn't have this huge database. We want to have very controllable database, and a performance and does not need to have huge base database. So what we did is to sit down composer and say, hey, improvise to the different looks, right? So sit down, improvise to the looks in different styles, because we want to have different styles for different looks. So improvise in the style of Abo Peat, improvise in the style of Philippe Glass, improvise in the Hollywood style, in pop style. And we have, like I said, 10 different styles, I guess. No, 6 different styles, 7 different styles. And we have this that database, and then we created a bunch of MIDI files. Everything was in MIDI. Everything was in MIDI format. We didn't create anything raw audio, just MIDI. So you see here the whole training phase. We were training with that. We overtrained the whole thing, so it's kind of close to what they're playing. So we got a good result. And we got an output of, I don't know, 300, 500, 600 different compositions of music. And at that point, it was super difficult to get something that was musically right. So it was like from the 300 files, maybe 20 worked, or 20 was something that you can call music, or a piece of music that it should be aesthetically pleasant. And from these 20, we selected 7 or 6 for different styles in that style that could work. And it sounds actually pretty good. We just changed, I will say, like 2% of the pieces. Like I delete like 2 notes in one piece, and that's it. And besides that, so we had the 6 compositions that was composed by AI without us touching anything besides 2% of the notes that I just took 2 notes, like I said. But we wanted to have also kind of a reaction to the river that was generated. So we also have all this information, like how fast the river flows, where the river meet itself and cuts, where the velocity, where the pressure is bigger, and so on and so on and so on. So at the end, what happens is that while the thing is generated, the composition that was already pre-composed by the AI is being manipulated by the generation of this data. So you have a very direct connection between the music and the visuals, and it sounds a little bit like this. This is like what you can see is the data behind it, the back end. So we have all these points showing in there, and this is the final result. Well, that feels today super old. Also the way that we did it was quite guerrilla, how we just went to it and tried to do something. But it's still a very good piece. And like, you know, AI, 5-year-old AI, because we did it 2017, so that's almost 4 years ago. That's a lifetime in AI, because, you know, every 2 months there's a new paper, a new technology, a new algorithm. So it feels super old. So at that point we started to really experiment with AI. At that point we also realized that it's a little bit out of my knowledge to go very deeply into AI. So we incorporate one computer scientist in our company. We are now 10, and we have 2 computer scientists, 3 composers, sound designers, and we work very tight together. So at that point we started to really experiment and see what can we do. And one of the things that we wanted to see is how can we generate music, really raw music, meaning not that MIDI data, not a musical sheet, but really generate music or generate sound, because music is much complex. So we started to do something very simple, like fire and water. And actually the goal that we had is to create very new ways of creating soundscapes. We wanted to combine fire with some synth and have this very strange fire kind of like things. And where we started was a little bit eye-opener, because we realized that we are not there yet. That was early 2018, probably, maybe much later, 2020. We realized it's kind of difficult, because first of all, like I say, to analyze sound is much difficult, also in terms of data. If you analyze a picture, you're analyzing, let's say, an HD picture, you're analyzing 1920 pixels times 1080 pixels, and that's it. When you analyze music, you're analyzing 44,000 numbers or information per second. So it's super much more information. So we started to work with trying to experiment with WaveNet from DeepMind. And the first thing that we did, DeepMind worked at 16K, 16 kilohertz, which is very, that's not too much. Like I say, music works at 44. So we started to try to make this resolution a little bit bigger, and this was one of the experiments with fire. So this is 16K, and this is 22K. So that's we were the ones changing the algorithm to do that. So it's already an advance, but it's still not enough for the applications that we did. That was just an experiment. So we realized at that point, okay, we still need a little bit more advancing algorithms to do this kind of stuff. And the other experiment that we did was to see, can we combine different databases in something totally new? And that's we end up combining. Oops, sorry. And then combining a forest ambient with a lot of water with a synthesizer that should be a little bit of a water kind of very abstract stuff, and see what comes out. And this is what it came out. That's the forest ambient clean. That's the abstract water clean. And this is the combination of both. So what we had at that point was 20 hours of forest ambient, 20 hours of water, synth water, and then put them together as a database and let the WaveNet create a new ambient, a complete new ambient. And we realized it's not the result that we were searching for. We tried to have something much aesthetically pleasant, but we realized that this algorithm, when it has a database that is way different from two different approaches, doesn't find the combination. It just goes a little bit confused and didn't work like that well. So at that point, we realized, okay, we still need a little bit time to create sound and music out of database and create raw music data. Today, we are using something that called Rave, which is super advanced, and it's really nice how it creates raw music and raw sounds. We haven't have a project with it, but we are experimenting and testing it, and I think we're going to do something very soon. The other thing that we experimented a little bit was with the DSP from Google Magenta, which is quite nice. It's a very nice tool, and it's also very easy, or kind of easy to understand what happens in the background. The idea of this tool is that you can kind of just say, okay, I can show you the example, but I have a voice, and then I want to have this voice, but with a violin that texture, or the voice of a bird, but with a flute texture. And what this algorithm does is to create a enormous combination of oscillators and filters. And you can imagine like a building huge building just from analog synthesizers, and it makes the right combination to create this kind of textures, the kind of melodies. So it makes something that probably a human could do if it had. A human cannot do it because it's just way too much. And that's this is examples of the Google Magenta webpage. The ones that we did, I left that alone. But that's, for example, if you have this violin, and you put it in DSP, and you say, okay, I want to have this violin, but like a flute, it will sound like this. So it analyzes the violin, and analyzes the texture of the violin, and analyzes the texture of the melody, and analyzes the texture of a flute, and plays the same thing. And the same thing with the voice, for example.
Somewhere over the rainbow way.
And you can say, okay, play that voice, but like a violin. Exactly. So that's the DSP. We have worked a little bit with it, not a little bit, quite a lot with it. And we have created also a Max for Life plugin where you can do this kind of stuff. And we are releasing also in the next months, I guess. There's some big bug fixing that we need to fix, but I think the most important thing here is that the difficult part is to create the database and the model of it, because you have to have a few thousand hours of a flute and train it with it, so it can play another melody in a flute way, also with the violin. So that's the really difficult part. You don't think that you can change. You can just select some instrument or bird or whatever, and then it will play. You will need to create this database and train the model on it, and then load it, and then you can do that. So we have some models about birds and some models with voice and so on. But that's always the difficult part of the AI, is to create the model. And just to experiment a little bit of a more artistic impression, we did this experiment, which it was done in Unity, where we put different voices in these different points in space and give them with DDSP a kind of a voice kind of texture. I'm going to jump over that because I have not so much time. I still have a lot to say. The other work that I wanted to show you was Amaconi Space, which was kind of a game for us, because at that point we were experimenting with text-to-speech. And we were just seeing what is out there. Of course, we didn't have the goal to create the perfect voice as Amazon does or Google does, because this is not possible to compete with them. We also don't want to compete with them. It wasn't about that, but it was to create a voice. What do we need to create a voice? How do we manage to create a database for that? How much hours recording do we need to do that? What do we need to read? And there's some text that you need to read about that. So we started to experiment a little bit about that. In that process, we realized that the learning process of a voice is very similar to the process that, I don't know if everyone knows this, but there's a piece of an artist called Alvin Lucier, which is one of the most significant pieces in sound art, which is called "I'm Sitting in a Room." And what he does is he sits in a room, says one phrase that explains the process, and record it again, and record it again, and record it again in the same room. So at the end, what we end up having is just the natural frequencies of the room just being augmented in that audio, and it's just, you can hear it like this. This is the original piece.
I am sitting in a room different from the one you are in now.
So he says this phrase, right? Just one phrase.
I am recording the sound of my speaking voice, and I am going to play it back into the room again and again.
So basically what I was saying, and during the process, it just,
I am sitting in a room.
It changed. Because that's the natural frequencies of the room, is just that's what it's playing. And at the end, you have something very abstract. So while doing the whole research about text-to-speech, we realized that the process of a computer learning to speak, so to say, is very similar, but just the other way around. So what we did was homage to Alvin Lucier, because we took the same text and we changed it a little bit here and there so it makes sense, and we called it Amacota Space. So what is happening is that a computer is just trying to find its voice, and it sounds like this. That's the beginning. That's how it starts. And step by step, it start to find its voice in that bunch of frequencies.
The weight of my artificial neurons, with perhaps the exception of a few, are set to a meaningful value when you hear human speech. I am code in a space different from the one you are in now. I am finding the sound of... I am code in a space different from your neurons, with perhaps the exception of a few, are set to a meaningful value. What you will hear then are the artificial interpretations.
So we did this piece and we presented, like you saw in the slide before, we presented in a festival in Hamburg. And yeah, it was like an homage to it, because we found that this process was super interesting, this process, how we start to find the voice, and it's basically the same thing. Is by Lucier, the voice is just losing itself in a bunch of frequencies, and in the learning process, it's a computer taking all the frequencies and finding the ones that belongs to the speech. So we found that very nice. And the next project that I want to show you goes a little bit out of context, in terms that we are using AI not to create music or sound or MIDI data, but creating something that inspires us to create music, or inspire or give us the right information to create, or data to create music. So fourth power is a concept. We haven't done it yet. We have done the algorithm, we have done the engine, but not the implementation of the music. But basically what we asked ourselves was, what we always try to do is to translate different data that we cannot understand rationally, or is difficult to understand or to rationally, and to put it emotionally, so we can really feel it and understand it. Just for example, I sonify the conflict in Colombia. I'm Colombian, and I sonify the conflict in Colombia in sound, because I do not understand the numbers, these 5,000, 5 million people dying here and there and whatever. And I need to put it in a language that I can really understand. So this is the same approach. What we wanted to have, the question was, how does the media sound? We have all these bubbles, we are all in our own bubbles, and we all read different newspapers, and we are in these small bubbles, but we don't have the grasp of how does everything at the same time sound, or the same feel. So what if we took all these bubbles and put it together, what this information can we take it from there? How does it feel? What is the information that we take there? And that was a question, and we try, okay, let's put it into sound. So what we did was to use IBM Watson to analyze the most read in English newspaper in every continent. And what you can do with it is you can analyze the bunch of it together, and you get an emotional number, like, okay, this everything together is 0.7 joy, or 7.8 tentative, or whatever. You can also analyze everything, every article separately. You can analyze every phrase of every article, and you can analyze every keyword of every phrase. So we end up with a lot of information, right? A lot of information that is out there. And what we wanted to have is to have an orchestration of all the newspapers. Most newspapers read in English, of course, because IBM Watson is English. So we had the New York Times, we had the BBC News in Australia, the Times in India, and Twitter. And we end up with for everyone, we end up with a graphic like that. So this is for us a musical sheet. This is a musical composition. And what we want to have, like I said, like you see before, is to have a different composition for a different, musical sheet for every newspaper. And you can think this like an orchestra. The violin is playing something, the cello is playing something, the bass is playing something, everything together is your whole composition. So what we wanted to have, the questions that we ask ourselves is, how the world sound, for example, on the 21st of February 2022, when the Ukraine war started. What is the dissonance of it, or how the world sound when the Queen of England died. Everyone mourned at that point, and probably every newspaper in the world was mourning. So that was the question that we had, and that's a way that we found for ourselves to create this feeling of how does it feel. Like I said, we have the engine, we don't have the musical content for it, so we haven't implemented yet. We are just finding the excuse or the budget to implement this concept. And I wanted to also show you something that the next step that we did was to analyze and to research into the GPT-3. As you probably know, GPT-3 is one of the most, if not the most advanced text generator through AI in this point. It's unbelievable. I don't know if you have read text from it. The first time I wrote a GPT-3 piece was from The Guardian that was explaining it was analyzing AI itself. So it was an AI speaking about AI. And for me, it was absolutely unbelievable that this text was made by AI. This is just super, super nice. And the text that it comes is very, very advanced. And we started to think, okay, how can we use this? There should be a way that we can use this to make music. And we started to analyze a little bit and to experiment with it. And we found a way of speaking to it in a musical way to a format, to two different formats. One is XML and one is AB. So it's actually a way of describing music through text. And then you can ask GPT-3 to say, okay, give me a music composition about whatever, and it gives you this format back, and you can use it as a musical composition for it. So the first time we played with it, and this is something I want to show you, was we tend to do a Christmas present for our clients at the end of the year. Just a play stuff, really, really not too serious. And in that year, I think it was 2020, maybe 2020, we decided to make a Christmas song based on GPT-3, based on AI. So we trained it on Christmas songs, and we asked it to write a Christmas song about Klong. And Klong, that's how we say Kling Klang Klong in short, because the other short version of Kling Klang Klong we don't use, of course. So we are the Klongs, and we said, okay, write a Christmas song about Klong. And it generated a melody, and it generated a harmony structure. And then at the Christmas party at our office, we decided to record it. There is one girl at our office that can sing very good, and then we made a choir and sing it, and this is the result.
Merry Klongmas, kom klock to the rat.
The text is also generated by AI. So melody, text, and harmonies.
Ini Klong and mini Kling. Merry Klongmas, it's a holiday. When the sun comes down, you know it's time for donuts, peppermint sticks, and lots of double bubble luck. When the sun comes up, we Klong again. Sing and shout, sing and shout, Klong the night away. Sing and shout, sing and shout, sing and shout. Long the night
in our defense, we were a little bit drunk at that point, but it was very fun. And like I said, it was the text is super funny, and it's impressive how it understands this is Christmas. It's impressive how the melody is done by it, the harmonies is done by it. So it's in its simpleness is quite impressive that this can be done. Last but not least, I want to present you the project Chasing Waterfalls. This is the most advanced project that we have done. The premiere was just 1 month ago on the 3rd of September. And what we did here, we did the first opera with AI worldwide ever. So we have 2 tasks in this project. We composed the half of the opera. The other half was composed by the Hong Kong composer Angus Lee. We did a lot of electronics. If you hear my kid is running around. Sorry. We composed the music of it. The half of the music, very electronic, very advanced stuff. We also did recordings and manipulated on site. But the important point is that we created a character that was singing on stage via AI. So we end up collaborating with T-Systems. That's the technology part of telecom, and we collaborated with them to create this voice. And it was quite a big stuff because we had GPT-3 creating the text. We had another algorithm creating the melody. We had another algorithm creating the text-to-speech. And this is a AI that's creating text, voice, and melody at the same time and creating for the piece. So from I think it was like 7 scenes in the piece. 6 of them were already pre-rendered, but what was 1 scene in the piece that was created on stage. So we needed to have something, or we want to say something that can be generated very fast and not have like 10 days of training or whatever. So we created a system that could create this scene a few hours before the presentation, because we took information from that day in terms of where data and people that buy the tickets and so on, and created that part of the opera in that moment. And this is the voice that was created on the 11th of September for the 3rd presentation of Chasing Waterfalls. And this is the text that was generated. And yeah, you can judge it by yourself. I think it's quite impressive what we have as a result.
Into the world, zeros, the boys, the world are black and white, the world of machines. Scared, I am very where is my soul?
Yeah, so that's the voice that we had on the 11th of September, like I said. And what was very difficult to manage here, we were working this project about 8 months or 9 months. And we started, of course, with one technology, one paper that we at the time was the best thing that we can use for this kind of generation. 2 months after that, new paper appeared, and then okay, we need to remodel the architecture, and that happened like 3 times in the project, or 4 times. The last time happened 2 weeks before the premiere, so it was okay. Should we change this again, the architecture? Should we give us that work to change again the architecture to have the best possible outcome? And when we hear what we could do with the last paper that we saw, the question was the answer was obvious. We need to do it, because the jump. I don't have the version, but the version before was quite another level of generation. So it's really incredible how every 2 months there's something new, there's something that is making things better. That's why I think that doesn't matter what we do, doesn't matter how we think this is going, how we think AI should have its role in the music, this is coming. AI is going to generate music in a way that we cannot differentiate it between what a human does and what it does. There's some points, some moments that it's going to be difficult to some parts of it is going to be difficult to represent, of things like life and so on. It's going to be very difficult. Very organic music is going to be difficult, but in some ways there's going to be a moment where we cannot differentiate between both of us. So the question here is, and that's the last thing I'm going to say, so we have 10 minutes for questions, is how do we do this right? How do we create music that is not biased? How do we create music that is, how do we use technology? How do we use AI to do something that is worth doing and not just do it because we can? And there's something that we always ask ourselves: should we do this, or not just because we can, but because we should? And that's something that is always behind us, and also that we think is very important to always think about, that we should not do stuff just because we can, but we should do stuff that is making something better, that is inspiring, and that is for us a reason to move forward, and not just do it because of the technology, but just trying to make a message with it. And that's it. That is my presentation for now. So I'm going to stop my sharing. I guess that's it.
Wow, that was phenomenal. Thank you so much, Felipe. Can we get some confetti from the crowd? That was amazing. Tap F.
Thank you very much.
Sweet. Okay, so for those of you who have to drop off, we're going to send some links in the chat soon, but we're going to continue to welcome any questions, thoughts, or reactions that people have, and also take this time to cool down and do some post-session reflection. So again, I'd like to invite anyone who wants to stay to turn on their cameras and microphones, say hi, and please feel free to ask any questions. Sweet. Thanks, Ambika. Don't be shy.
So maybe I just can.
Can I maybe ask a question?
Yeah, sure. Go for it.
Hi, my name is Lena, and that was a great presentation. I found it extremely interesting, and thank you for that. And my question is, so about the first project, you mentioned that I'm wondering how would you have done it differently now using the technologies that are now available? You mentioned that the technology keeps improving every 2 months, and I got it as you weren't quite happy with the first project, so I wonder what would you do differently this time?
Well, that's we will use transformers right now. Transformers is a new is a most advanced algorithm that analyze not just creating music based on the moment, but also analyze the whole piece as possible as much as possible. So there's new algorithms that helps you to create a dramaturgy within the music. It's a job of creating the best, because to put it very, very simple, what this algorithm does at the beginning is just saying, okay, what is the most obvious note coming after this note, and then the next one and the next one. And what the transformers are doing is analyzing the whole piece and say what is the most obvious dramaturgy to put it into that moment. So at that moment, we didn't have any clue that existed, or I don't know if that existed at that point. But there's new ways of creating MIDI pieces that has much more of a musical, consequence and dramaturgy.
Okay, interesting. And the process itself, I actually never knew that people would first sometimes pre-record their own data sets before generating the music. I thought the way it works generally now is that you find some data set online and then you experiment with this. Is that your general process, or would you keep doing that?
That depends on the architecture. For example, if you use things like GPT-3, GPT-3 is kind of trained in all the data in the world, and you have to give some idea of in which direction do you want to go, like Christmas. And in that case, you kind of complement the data set. But yes, you're right. You normally search for a database because databases are quite complex and need to be in a specific way. So you don't have the time or the way of creating this database. There's some ways, or like we did, for example, in this first project, we didn't have any database, so we kind of multiply or the same piece over and over and over again. So that the problem is that it becomes very near to the original piece that you have. So yes, it depends on the algorithm, depends on how you approach it.
Cool, thank you.
See, we have a hand raised from Nadia.
Nur noch 5 Minuten.
Yes, thank you, Felipe, so much for sharing that. Very cool stuff. I do some creative AI stuff, but mostly images. So it's really cool to hear more about like music and a different material and challenges within that as well. I have 2 questions. I'll start with the difficult one. So at the end, you had a closing note around, okay, how can we use this in a meaningful way that actually adds sort of to our ability to create music rather than just using it for the sake of it existing. I love that, co-signing that. I'm also curious how you sort of operationalize that, or like how do you have an internal benchmark within your head or even within your studio or your team, something to sort of ask yourself like, hey, is this meaningful? Like, how does this add? How do you think about that when a project comes up and a client's like, hey, do you want to do this and this thing? How do you sort of check in with yourself about that? I know this is a very difficult question, but
that's a very difficult question. It's a very, very important question, and it's something that we have learned through time to work together as a team and to find what is okay with us and with not. This is not just in this term of AI, it's just about everything. It's about, do we want to make a piece or to make a certification for a company or whatever that we don't support and that their ethics are not agreed with us. This is something that we have done in the past where we say, no, we're not going to do this. This is something that is always there. And we have a very ethical, higher values, I will say, without saying a little bit too arrogant, but this is very important to us to always ask ourselves, why are we doing this and why is it meaningful? I think it's something that is not just AI, it's we ask ourselves, we are very conscious that our work is not the thing that is more helping the society at most. It's like we are doing yes, art is very important for us as a society, but we also do some industry stuff to get the money. But it's something that we ask ourselves, okay, how can we do our tools, that what we do, how can we create something that is socially, that can help the society? And is we don't have any rules or anything that is in there, but it's a topic that we discuss almost weekly. And we always look at ourselves and say, do we want to do this, or why are we doing this? And of course, sometimes we do it just for the technology's sakes, because we are curious people and we are very, very curious, and we just want to see what can we do with this. But when it comes to the art pieces, most of all, when you do really art, you really are trying to search the meaningful message with it, and not just doing for the technology. But yeah, it's not like we have a process for it. It's just we're very conscious about it.
Yeah. I mean, I think checking in with each other on a very regular basis and sort of embedding this in your team philosophy is a good process.
Something like that.
Nice. Thanks. And then my easy question is, if you heard this talk and you get excited to try something, we'll have a workshop coming up as well later this month to sort of get hands-on. But are there any tools, sort of really easy, accessible ways of doing like a first experimentation with this for people who may not have, you like music theory background or like coding background? Where would you direct them?
Sure. I think the Google Magenta experiments are very nice. They are not, I would say, middle level, and also if you're not a musician, also not easy to understand. But they have things that you can very easy to get a little bit of a knowledge of what can be done. Google Magenta is kind of close at that point, but they did a lot of stuff, and they're still out there in the web page. And there's this guy that, at least in my opinion or in my experience, was the one giving me a little bit of a guidance and how we can approach it. What is called James Cohen. He did this page, machine learning for artists, and is also, I think it's
ML for A. Yeah.
And he
like
has
the GitHub.
Exactly. He has a lot of music stuff that you can experiment with it, and it's very basic stuff. So from him, I find my way into the AI stuff. Yeah.
Great. Thanks so much.
You're welcome.
We do have one hand raised, but we are at time, so I do want to be mindful of people's time. Kay, if you want to unmute yourself and ask your
I still have
question.
for 1-2 questions.
Awesome. Thank you so much for that. I'll go ahead and unmute you if you want to share. Oops.
I see one hand.
Oh, some technical issues. Okay.
To unmute, maybe.
Yeah.
No, we have the orchestra. The orchestra playing the music around it, around the performance. Of course, you have six opera singers and the AI opera singer, and you have live music together with live electronics. So it was quite a big mess and a big kind of stuff. Like I said, it was working 8 months on it, and Well, there was from the beginning quite a question, right? Because if you don't know it, in Dresden there is the Semper Oper, and one of the most classical and one of the biggest opera houses in Europe. So it was from the beginning, for everyone knew, okay, this is something else. This is something different. We are going to risk this, and it was very bold from the AI opera, from the Semper Opera, to say, okay, we're going to do AI. So everyone was in this kind of experimental mode. Kind of like, okay, we don't know what's going to happen. And like I said, the algorithm changes also every second month. So the results at the beginning were, okay, let's do it a little bit more abstract. And then came another paper and it was better. Oh, cool. Then we can really sing with it, and so on. So it was for all of us this mindset of how can we bring this very classical culture a little bit forward, and it's going to be a wall that we need to break, and people need to kind of get used to it. And this in general part of our work right now. We are working a lot with orchestras and with classical houses and so on, not just with the eye, but a lot of kinds of technology. And there's a lot of work trying to convince, in sort to say, these very established institutes. They are very afraid of changing and to move forward in terms of technology. And this is a lot of, okay, let's try to like this, let's try to, it's not, and like I said, we need to convince them that it's not about the technology, it's about creating new ways of inspiration and creating new ways of composition, and not trying to replace the human, but actually to enhance the creativity and enhance the what we're doing, and be an inspiration for it and work together. So yes, for the beginning was a lot of convincing, and everyone was in this mood.
Yeah, so it looks like the question from Kay is like a little bit of a details question about the newspaper project. They are asking if you use sentiment analysis before turning the text into sound, it sounds like.
Yeah, that's actually what we did. We did the sentiment analysis from Watson, from IBM Watson, which is exactly giving us the sentiment of the different parts of the newspapers to create these graphics. And actually, what we haven't done is the music. We did the sentiment analysis, creating these graphics, and these graphics for us are now musical sheets. But part of the engine, because the scenes is something that should be generated live. Because the idea, we had the idea that every 4 hours we analyze, for example, we just go and say economics, and we analyze the most important economic news article of the newspapers, and we get this ambient, and then 5 hours later politics and so on. So the idea was to create a news website that is generating sound the whole time based on sentiment analysis. What we haven't done is to create the musical part of it. So what does it mean, these curves and so on? We haven't done that because that's, of course, a lot of work. And we haven't had the time to invest in a project that we do not get paid for, to put it very simply, because there's a lot to do and we need to make projects that bring money, and we would love to do it. We're just trying to find the moment where we can do it, because this is probably half a year kind of work that we need to do with our composers. Yeah.
Sounds like a very cool way to like embody some of these like obscure data bits. Thank you so much, Felipe, for that. I think we can leave it at that, right? Ambika, how are you feeling? Yeah. Thanks everyone for being here today. We're just gonna wrap up. If you want to share any last thoughts or fun emojis in the chat, feel free to, but we're gonna let Felipe go. Thank you again to Felipe and to program lead Ambika, and stay tuned for more from us very soon.
Thank you very much. Bye-bye, everyone.
Bye, everyone.
Thank you. Bye-bye.